If you know the equation that describes a line, you can find its slope by using any two ordered pair solutions, right? We know that. We use the slope formula. So if you have two ordered pairs, we call one our first point, we call the other one our second point, and then we stick them in this, the formula and find our slope. So it is often easiest to use the ordered pairs that contain the intercepts. Oh, that's interesting. So we're going to kind of be using intercepts to find the slope. Okay, so let's go ahead and look at that. So we have example 4. So we're going to be finding the slope from an equation. So we're going to find the slope of a line described by this equation, 4x minus 2y equals 14. And remember, this is in standard form, right? So the slope formula, we need 2 points. Do we have 2 points? We do not have 2 points. So what are we going to do? How are we going to use the slope formula to find the slope? Well, we are going to have to figure out 2 points, and we can totally do that from what we know about our x-intercept and our y-intercept. And let's go through it. So if we find the x-intercept, what do we always know about the x-intercept? Well, we know that y is equal to 0, right? Perfect. So I'm going to go ahead and write that original equation. And then I'm going to stick in 0 for y and see what happens. Okay, that becomes 0. We have 4x equals 16. We want to get x by itself, so we divide by 4 to both sides, right? And we end up with x equals 4, but we're not going to write that because we're going to say the x-intercept equals 4. Or what we're more importantly going to say is the point 4 is x and y is always 0. So we have a point. So if we have an equation like this and we don't have any points, we can actually figure out 2 points by finding the x-intercept because the x-intercept is a point. So guess what we're going to do now? We are going to find the y-intercept because what do we know? At the end of it, we're going to end up with a point. And then we're going to have our 2 points, and then we can use the slope formula to figure out what the slope is of this line. So let's go ahead and do it. So the y-intercept, what do we always know about the y-intercept? Yes, x equals 0. So we're going to go ahead and write that original equation, 4x minus 2y equals 16. We're going to substitute 0 in for x, so we have 4 times 0. Okay, that's equal to 0. We have negative 2y equals 16. We want to get y by itself, so we divide both sides by negative 2. Negative and a negative is a positive. 2 divided by 2 is 1. 1 times y is y. Now we have y by itself. 16 divided by negative 2 is negative 8. So, but we don't write our answer like that, right? We are looking for the y-intercept, which is just a singular point. That is a horizontal line, right? There we have it. Y equals negative 8, which is the point 0, negative 8. Perfect. Oh, I got to put that ordered pair. So now we have our 2 points. This is amazing. This is great. So we can go ahead and figure out what the slope is now that we have 2 points from our equation here. So I'm going to call this my x1, this my y1, this my x2, this is my y2. And then I'm going to use that slope formula. M equals y2 minus y1 all over x2 minus x1. And then substitute those values in. So y2 is negative 8 minus y1 is 0. All over x2 is 0 minus x1 is 4. Okay. Now we just simplify. Negative 8 minus 0 is just negative 8. All over 0 minus 4 is negative 4. A negative and a negative is a positive. And 8 divided by 4 is just 2. So our slope is equal to 2. Isn't that so cool? We just had this equation. We found the x-intercept, which gave us a point. We found the y-intercept that gave us a point. And then we could use our slope formula to figure out what the slope is. All right, perfect. So here we go. This is check it out example 4. I want you to go ahead and try this process on your own. So you're going to find the slope of the line. All you're given is equation. So remember, you're going to have to find that x-intercept first, the y-intercept first, then use those 2 points to and put them into the slope formula. So really use this as a guide. Your work should look exactly like this, okay? So here we go. Go ahead and get started. Here's my friend the pause dragon. Remind you to pause your device. When you get done working this problem out, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. So we have a line, let's find the slope. So we're gonna determine what that x-intercept is, right? And we always know for every x-intercept, y equals 0. I'm gonna write that original equation, 2x plus 3y equals 12. Substitute 0 in for y. That ends up being 0. We divide by 2 to both sides. We get x equals 6, which is our x-intercept, equals 6, which is the 0.60, which is what we need, right, for the slope formula. First point, done. Let's go ahead and figure out what that y-intercept is. And what do we always know about the y-intercept? Well, we know that x equals 0. All right, let's go ahead and write that original equation down. And then we're substituting 0 in for x. 2 times 0 is just 0. We're left with 3y equals 12. We want to get y by itself, so we divide both sides by 3. We end up with y equals 4, which is really where we found the y-intercept is equal to 4, which means it's the point 0, because x is always 0, 4. Perfect. Now we have our 2 points. We just need to go ahead and use that slope formula. So I'm going to go ahead and define my terms. This is my x1, my y1, my x2, and y2. I'm going to plug them in. My slope formula, m equals y2 minus y1 all over x2 minus x1. I'm going to substitute those values in. 4 goes for y2. 4 minus the y1 is 0. All over my x2 is 0 minus my x1, which is 6, which ends up being 4 and negative 6. Then we just need to simplify. Is there a common factor here? You should have saw that there's 2. 2 goes into 4 2 times. 2 goes into 6 3 times, which means we end up with our answer negative 2/3. So our slope equals negative 2/3. So if you got that right, yokodenki mashita, you did a wonderful job, and I will see you in a little bit for the next lesson.